All right, so the last section, 5.1, we talked about the beginning and end behaviors and how many turns they could possibly have. And we're about to start getting into the actual sketching actual graphs and understanding their behavior even more. So the first thing we're going to do in this lesson is we're going to recap what the vocabulary is. So if you see the words solution, x-intercept, zero, root, all of those mean the same thing. It's where it crosses the x-axis. And that's what these polynomial functions are really focusing on. Those are the solutions of where they cross. So if you see those words, just know that they're all interchangeable and they're all the same thing. Okay, this next part is I'm going to recap on how to factor. In case you forgot, we've been doing it a lot. There is a typo in this one. Let's make that to the second power. Okay, so first thing we need to do is factor out the GCF. So in this case, that would be 3x. So you would get 3x squared plus 2x minus 1. Okay, so now don't forget about that 3x up front, but we can factor with the product sum method what's in the parentheses. So we're going to see what adds to be 2 and multiplies to be 3 times negative 1, so negative 3. So that would be a positive and a negative, and the bigger number is positive, so it looks like 3 and negative 1. Remember, since there is a term out here besides 1, we do have to factor by grouping, so keep that in mind. So we're going to have that 3x, so 3x, and then this would be 3x squared plus 3x minus 1x, or just x, minus 1. All right, so now let's factor by grouping. So that would be still 3x out there, and then that you could factor out a 3x from there. That would give you x plus 1. It looks like here we can factor out a negative 1, so that would give you x plus 1. Oops. Okay, now double check. Is the stuff in your parentheses the same? Yes, it is. We are good to go. So this would be 3x, don't forget about that, times 3x minus 1 times x plus 1. And that is in factored form. Okay, let's do another one. Okay, so now on this one, we have to factor out the GCF first. It looks like it's just a singular x. So that would be x squared minus x minus 12. Now we do the product sum. So what adds to be negative 1 and multiplies to be negative 12. Actually, yep, positive and a negative, and your bigger number is negative. So that would be negative 4 and 3. On this one, do we have to factor by grouping? The answer is no, because there is no number in front of the x squared. So we can just throw it in. So this would be x times x minus 4 times x plus 3. Boom, that's it. That was a much quicker one. Okay, so now let's start this. We're going to find the zeros. So if you forgot how to do that, remember you set each piece. So set this piece, and then this piece, and then this piece equal to 0. So that'll be like x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Okay, so this would give you that x would equal negative 2, positive 1, and positive 3. So what does that represent? Well, that represents where it crosses the x-axis. So we have a point at negative 2, positive 1, and positive 3. Okay, so let's talk about which way do we start? The end behaviors. Remember, we have to look at the leading coefficient, whether it's positive or negative, and whether it's even or odd, the exponent. So let me show you a shortcut on how to do this. You could take the time to distribute all of that out, but I'm not going to. So for your leading coefficient, all you have to do is multiply the leading terms and the parentheses. Okay, so in this case, this would be, we would multiply x times x times x. So our leading coefficient would be, for this one, it would be x cubed. Okay, since that is a positive leading coefficient, and it's odd, that would mean it would start down and finish up, if you remember from yesterday's lesson. So if it starts down, it's going to look something along these lines. And this is a rough sketch. We're just trying to get the idea of the behavior of the graph. We don't know how far up it's going. We're not getting into all that, or how far it's dipping below here, or what these lines, how fast they're trending upwards. This is just the overall shape of the graph, just getting you familiar with it. Okay, and the next one. So first we need to find the zeros again. So that would be x equals 0, x minus 3 equals 0. That would give you positive 3, and then negative 5. So I'm going to go ahead and plot these. So 5, 3, 0, 3, and negative 5. Okay, the leading coefficient with this one would be x times x times x, which again is x cubed. So it starts down and then finishes up. So let's graph this, and it would look something, it's similar to the last one, like that. Okay, so now let's go ahead and get into they're giving you the zeros and you have to put it in standard form. So it's going to look like something like this at the beginning, okay? Or at the end. So how do we get there? Well, first you have to get it to this right here. So we have to put it something like this. So what would it be for x to equal negative 2? Well, if you were going to set up that equation, that would be x plus 2. Because if you set that equal to 0, you would subtract 2 and you would get negative 2. Okay? The other one, to get that positive 2, you would have x minus 2. And to get that 3, you would do x minus 3. I had a brain fart. Okay, so now we're ready to put it into standard form. So all we're going to do is just distribute everything out. Go nice and slow, so that way you don't make any mistakes, because it is easy to make a mistake on these. So I'm going to do the first set of 2 sets of parentheses, so that will give you x squared minus 2x plus 2x minus 4. All of that, and we still have this one over here I can't forget about. Okay, then I'm going to clean this up. It looks like this middle part cancels, so that would give me x squared minus 4 times x minus 3. Then I'm just going to distribute again. Would give me x cubed minus 3x squared minus 4x plus 12. Is that in standard form? Yes. Let's get crazy and throw a y equals in front of it, because it is the equation of a graph. Okay, so that is what they're looking for whenever they're asking you to do that. This next one is the same way. I'm actually going to pause the video and work it all the way out, because this one does take a while. So I want you to do the same thing. Pause the video, work it out, and then see if we get the same answer at the bottom. If we don't, then try to find out where you made a mistake. All right, wasn't that so much fun? So whenever you get it all multiplied out, you should get this answer. X to the 4th minus x to the 3rd minus 10x squared plus 4x plus 24. So if you didn't get that answer, pause the video, go check and see all my steps and see where you made a mistake. Okay, so this next part, this is where it starts getting fun when we're graphing these. So when you have an x-intercept, or solution 0, whatever you want to call it, with an even, that word is big right there, even multiplicity. What does the word multiplicity sound like? Multiple. So whenever you do that, it will create a bounce at that point instead of cutting through. So what I mean, if you have an even multiplicity, it'll bounce, so it will touch the x-axis and then go straight up. Instead of cutting through would be, I don't even have to draw it. This part would be the cutting through part. So it doesn't cross, it doesn't go through, it just hits it and then bounces up towards the other direction. But it's only whenever it has an even multiplicity. So an example of one with an even multiplicity would be this one right here, because of -2. That occurs twice. That's 2 of the zeros. Okay, so this one, doesn't look like we have any multiplicities, so we don't have to worry about it. So let's just sketch a graph. So it looks like there's an intercept at -2, 1, and 0. It doesn't matter which way you start because this is a sketch. They didn't tell us anything about end behavior, so we don't even have to worry about it. Just do whichever one you feel. I'm going to start from the top and go the opposite way. That's not my prettiest graph, but it'll get the job done. Okay, this one has a bounce, a multiplicity. So that would make a bounce because it occurs twice. So that graph would look something like this. -2 and then +1. Again, I'm going to start from whichever way. It doesn't tell you what the end behaviors are. So on this one, I'm going to change it up and start from the bottom. And then it goes up, hits it, bounces, and goes back up the other way. You also could have done the reverse. You could have said, oh, right, it does something like this. It can bounce coming from the other way. So either one of those would have been a perfect sketch. That would have been a correct answer that I would have given you. Okay, so, and again, this only happens when there is an even amount. So if there was a multiplicity of 2 or 4 or 6, then it would bounce. If the multiplicity is odd, like 1, or maybe it occurs 3 times, it goes through. Okay, so it's just something to keep in mind. Okay, then the last part of this is we're going to kind of put it all together. So it says, what are the zeros of the function? What are their multiplicities? How does this graph behave at these zeros? So first we have to find the zeros, and then we're going to sketch a quick little graph. Won't be anything too crazy. So how do we find the zeros? Well, we need a factor, of course. So this would be, let's factor out the GCF, which is x squared. So this will be x squared times x squared minus 2x minus 8. Okay, and now let's factor by the cross product methods. We need what adds to be -2 and multiplies to be -8. That would be positive and the negative, and your bigger number is negative. So -4 and 2. There's no number out here, so we can just put it straight in. We don't need to factor by grouping. So we would have x squared times x minus 4 times x plus 2. That one wasn't too bad to factor, was it? Okay, so now let's find your zeros. So your x is going to equal +4 and -2. That's the easy one. And then sometimes people will just want to say 0. Okay, there are your zeros. Actually, there's another one. X squared is x times x, right? And the only reason am bringing this to your attention is because that would mean there are 2 zeros. And why do I care if there's 2 zeros? Well, because that's an even multiplicity and that's where it bounces. So just something to keep in mind about that. So we're going to sketch a quick little graph, nothing too crazy. Looks like here's -2, here's 4. Let's do this. Our leading coefficient, we know on this one, it is a positive even exponent. So it's a positive coefficient with an even exponent. So that means it starts up and finishes up. Okay. So now it starts up, it bounces at 0, and then it comes up through 4. So it looks something like that, a big old W. Okay, so let's do that again for this one. This one's pretty easy to factor as well. It'll be our last problem. Let's factor out an x. So that gives you x squared minus 4x plus 4. So what adds to be negative 4 and multiplies to be 4? That would be two negatives, so negative 2 and negative 2. We do not need to factor by grouping. So this looks like this. So our zeros would be 0 and then 2 and 2. So there is a bounce again. All right, let's sketch a graph. We've got 0 and 2. So this one has an even leading coefficient and an odd exponent. So that would mean it starts down and finishes up. So it would look something like this. Okay, so that's kind of a rough sketch of what that function looks like. All right, that is it. I hope you enjoyed this lesson as much as I do, because it's a lot of fun getting to graph all these funky looking lines and stuff. Have a great day. Thanks for watching.